Hi folks. So before we can jump in learning some different topics of programming, I need to be able to talk to you about some of these concepts. So this video will be about defining these concepts, describing some of them so that we build a vocabulary and then we can keep on learning more and more. So let's start with the first term, which is programming. So what is programming? Programming is designing and building computer programs, putting it in a very simple way. And what is a computer program? Computer program is basically a sequence of instructions which can be executed by a computer to perform a specific task or a calculation, which is also a task. So when I say designing and building a computer program, let's understand what does designing and building mean in this context. So designing is the part when you do the thinking and analyzing the problem, understanding what type of entities you will need, what kind of functionality your program should provide, how to model relationships between the entities, what algorithms you might need to use for solving your problem, what data structures, and maybe what programming language is preferable, and things like that. So once you have the full picture in your mind of what you're going to do, how you're going to solve this, then designing part basically is done. Then you go to building, which is taking whatever you planned, you designed, and implementing it, which means picking your tools and the programming language and writing your program, the source code for your program, and then building it, running it, writing tests, verifying that basically whatever you expected your program to do, it does. So that's the building. So designing and building means you think about it, you come up with an idea, you implement that idea, and you verify that your idea is actually working and doing what you expected it to do. So when I said the computer program is a sequence of instructions, so what's an instruction? So instructions are actually machine specific. They are more basically closer to the hardware layer than the software. So they are machine specific. Let's call them keywords. I think at this point I don't want to go into all these details, what instructions really are and how they are handled. But for now, let's take them as they are some kind of keywords that your machine or the processor understands. So when we say the instructions are executed by a computer, again, I think this deserves a separate video, so I'll make one about this, the machine level instructions and their execution. But for now, let's think of this as your computer understands these keywords and knows what to do with each one of them. So when you provide the list of instructions, it will just know what to do. It will just go one by one and execute them. So for now, let's assume that's good enough for this video. We'll come back to that. So the next term I think I used was a task, right? When we say we write a program to perform some task or a calculation. So task is basically anything you want to do or your program to do. It can be playing a sound, it can be printing something, outputting something on your display, it can be just calculating some large number or a function result for some number, and anything else. So a task basically is, in general, it's a very non-technical word. It basically is the same task. Anything can be a task. So in designing phase of the programming, I mentioned an algorithm. So what is an algorithm? Is basically a very specific definition, step-by-step definition of what needs to be done to solve a generic problem. So in other words, it's basically similar to a program, but it's again step-by-step instructions, but the algorithm is for solving a generic problem, not a specific one, and I'll tell you in a bit what it means. So also for algorithms, you don't need, it's basically an abstract way of defining, it's a formal, more closer to math definitions like functions. So it's a formal definition of a solution to a generic problem. So the difference, to illustrate the difference between a program and an algorithm, let's assume this example. Let's say you want to write a program that calculates the square root of a given integer. So you want to write that program, and your program would basically take a number, you will input a number from your keyboard, and your program then will print out on screen saying, okay, the square root of the number you printed is this, or maybe if it's unable to calculate, it will say some error, I cannot calculate. So that's your program. And the program actually, for calculating the square root, it can use different algorithms. So algorithm can be something that basically, for instance, takes the, let's say, starts from 1, keep increasing the number by 1, and multiplies the number by itself, and then if the result is your original number, then that's the square root. So that's one way to go. We don't care if it's efficient at this point or not, but that's one algorithm. Another, there is a very well-known algorithm called Arsen's method for a good estimation in very small number of steps. So basically, there might be different algorithms for calculating or doing the same thing, and there might be, one might be good in some circumstances, another might be better in other circumstances. It depends on your problem which one you want to pick, but the algorithm will be for calculating a square root of an integer or of a real number. It will never be calculate a square root of a 9 or of 16, whereas your program might do exactly that, calculate the square root of 16. So I'm not sure how well I described this. We will come back to this many times, and especially once we have examples of source codes, I will emphasize the differences again. So the next term I think I mentioned is programming language. So programming language, it's a formal language with all its vocabulary and grammar rules, and it's basically created for writing source code for the programs. And the difference between this programming language grammar and the vocabulary, and between the programming language instructions and the machine level instructions, is that programming languages are generally much higher level, so you don't need to know all the processor details, like your machine architecture details, to know what to write, what to do in this exact step. So programming languages provide instructions or keywords, or as I said, the vocabulary, which is more human friendly, or it's closer to natural languages like English, so you can understand it easier, you can write the code easier, and you don't have to worry about all the details. So you can, like, one simple instruction in a programming language can be eventually translated to thousands of lines of machine instructions. So that's another thing for basically making the programmer's life easier, and eventually also giving a way for other programmers also to look at the code, source code, and understand what it's written there. So I think there's a lot to cover about programming languages, and there are many, many different programming languages. Most of them, or not most of them, some of them are general, so they are meant to be used for solving any kinds of problems. Some of them are domain specific, so they are meant for specific types of problems, like machine learning. I don't know, there might be some about that can do calculations on the databases only, and there might be even like specific to your hardware. For instance, there might be some programming languages for programming your, I don't know, watches, wearable watches, or some other military hardware, and so on. And there are also different styles of languages, so I don't want to cover all the details here, but two generic categories are the declarative and imperative languages. So in imperative languages, basically when you write your code, you say in your each your statement or instruction says what the computer should do to achieve the final result. And in declarative languages, basically you say what you want to achieve instead of what the computer needs to do, and then all the tools provided by that language or for that language, they will take care of translating your declarative code into the machine instructions to do whatever you want it to do. So yeah, basically I think we covered how programming languages are different from machine instructions. So I think yeah, I told a lot of things. I'm not sure if you managed to digest it all or not. Hopefully I gave at least a little bit of idea what each term means. So let's jump into a quick example now to just make it a little better, and we'll be done in a couple minutes. So I gave you the same example, the source code for a program that calculates a square root of a number you input on your keyboard, and I gave it the source code in two programming languages, two different languages. So let's not go into details of what language is this or what each statement is doing, but basically the first line in both examples takes an input number, and then the second line calculates the square root, and the last line, the third line, outputs that value on your screen. So to kind of go through all the definitions of our terms, and on this example, let's think of this. So each line in this source code is basically a statement in a programming language, and in one, most likely if you take a source statement from one language, it won't even work in any other language, but there might be some exceptions. So all these words you see here, input, sqr, print, int, double, math, sqrt, so all these are keywords in a particular programming language, so they are part of the vocabulary, or yeah, they're called keywords basically. Some of them are keywords, some of them are just part of the syntax. So so the difference now, let's just emphasize again the difference between algorithm and the program, right? So this is the code for our program to calculate the square root of the number we give, and the algorithm to calculate a square root, we are not even aware of it. So we are using some existing functionality that the language provides. So for instance, in the first example, it's the SQR function, and in the second one, it's math SQRT. So we don't even know how the square root is calculated, like how much time it takes, how expensive operation that is. So we just rely on the programming language to do it for us. So that's the difference. If we would want to implement a specific algorithm to write the code to do it in a way we want, we would most likely write the whole code for calculating the square root instead of using just this function. So yeah, I think this is the code. We know the task here is basically to calculate the square root. The algorithm, as I said, we don't know which one is used. So we can test this code by writing another code, which is also a program, but it's for testing. So for instance, we can say input and provide input 9, and then make sure that it prints out 3. That would be a test. So yeah, I think this is good enough for this video. I'll create another one for going into details of machine instructions and how your computer understands those instructions and how it executes them and which hardware components are involved and how exactly all of these things happens in all the details. So I think that might be a bit tedious, but I think that's important to understand at least once, and then it will be simpler for you to understand all the workflows, how we build the program, how we run it. So I think this is good enough for this video. Thank you very much. See you in the next one. Bye.